Hello, welcome to another session of artificial neural networks. In this session, we'll develop our first neural network using Python. We'll have the step-by-step scenario. So first we have Anaconda which is installed, and we launch Jupyter Notebook, and we have downloaded a data set which is related to diabetics. And if you look at the data set, you can see several parameters. So the first entry is the number of times pregnant, and second is plasma glucose concentration, third diastolic blood pressure, next skin fold thickness, next 2-hour insulin, next body mass index, and next diabetic pedigree function and age. So, and the rest is a classification where whether this one has diabetics or not. So I have it in the same folder, and we have the IPython notebook as well. So first we'll do the necessary imports. Text from Keras Model import sequential layers and import dense. So this dataset bit can be downloaded from UCI machine learning repository. So it describes the patient's medical data, and it's available as a CSV file. Right, so first we'll have a look at the dataset by loading it. Load the dataset. So we'll get the name. So we'll split into input text and variable y. So input x and y. So input is x and output which is y. So those are variables. So x was data set set colon comma 8 colon comma 8. So here what we are doing is we can split the array into two arrays by selecting subsets of columns using standard numpy slice or with the colon operator, and we can select the first 8 columns from 0 to 7 indexes. So first 8 columns, here 1 2 3 4 5 6 7 1 2 3 4 5 6 7 and 8, right? First 8 columns is taken as variable x, so which is from index 0 to index 7. The first 8 columns were 0 8 command, 0 colon 8 command, and we can select the output column, the ninth variable, via index 8. So here we select the ninth column, so that is whether that has diabetics or not, that we are predicting. So we have the features here 0 to 7, from index 0 to 7, so the first 8 columns, and the ninth column is what we are predicting. Right, good. So far so good. So now we are ready to define our neural network model. So here we'll have 8 as the input, so we'll define Keras model sequential. So the first thing to get right is ensure the input layer has the right number of input features, so that is 8, and next we'll create the sequential model and add layers one at a time until we are happy with our network architecture. So the models here, then we use sequential. So sequential is the way that we create sequential models, and models in Keras are defined as a sequence of layers. So models in Keras are defined as sequence of layers. So we have sequential here, and then we'll model add. This statement is doing two things. One is dense input dimension equals 8. So that is, we have 8 inputs, and activation equals relu. So for the first layer we have the activation function as rectified linear unit, and next we have the sigmoid function. In past the tangent and the sigmoid were used, but now for better performance the relu activation function is used, and we use the sigmoid as the output layer to ensure the output is between 0 and 1. So for the next layer, and the first hidden layer has 12 nodes. So this statement is responsible for two things. So the hidden layer has 12 neurons, and the input dimension is 8. So the model expects rows of data with 8 variables. So input dimension is 8. The first hidden layer has 12 nodes, which is denoted by 12, and uses relu activation function, rectified linear unit. So let's have the second layer now. It has 8 nodes and uses the relu function. So we'll copy paste this. So it has 8 neurons, so it doesn't have this, and activation is relu. So the first statement is little bit strange because it does two things. It defines the number of neurons, and also it explains about the input. So input should have 8 variables and hidden neurons 12, and the second layer 8 hidden neurons and activation is relu. And the next layer, whether it's diabetics or not, so we have to predict. So that means 1 neuron, and for that we'll use the sigmoid activation function. Let's see, add value. See what has happened. Right, correct. So we define the model sequential and add the first layer, which has 12 hidden neurons, and input dimension is 8. So it does two things. So the model expects rows of data with 8 variables, and the first hidden layer has 12 nodes. So it has the input layer. The first statement, this statement does two things. It has details about the input layer and also the first hidden layer, which has 12 nodes. The next hidden layer has 8 nodes, and the final layer has only one hidden neuron. The activation function is Sigmoid. So we have successfully done the model, Keras model, and next we'll compile the Keras model. Keras model, model.compile. So for the loss function, we'll use binary cross entropy. So put loss equals binary cross entropy, optimizer add-on. Let's see what's it. So there's no H. Right. So here we use the cross entropy as the loss argument. This loss is for binary classification problems and is defined in Keras as binary cross entropy. So we define the optimizer as the efficient stochastic gradient descent algorithm, that is ADAM. So we define the optimizer as stochastic gradient descent algorithm. So it's a popular version of gradient descent because it automatically turns itself and gives good results in wide range of problems. So we use the ADAM optimization. So now we have to define our model and compile it ready, and it's working. We have already done it successfully. Now it's time to execute the model on some data. So we can train or fit our model on our loaded data by calling fit function. Let's see how we are doing it. Fit the Keras model on the data set model.fit x y epochs so let's say 10. So epoch is a one pass through all of the rows in the training set. So it's one pass through all of the sets, all of the rows in the data set. So we have the data set, it's one pass through all of the rows. So if we have many rows here, so it's one pass through all the rows in the training dataset is an epoch, and batch is one or more samples considered by the model within an epoch. So we will have batch size of 10. So one epoch can have several batches. Model fit. So it's capital. So we have this also simple. That's one spelling mistake. Sorry. Size. So you have to be very careful with the I typed it quickly. Okay. So model fit, x is the input, y is the expected out, the output, y variable. So epochs we have 150 and batch size is 10. So we can see the output. So first epoch. So epoch is one pass through all the rows in the training dataset. So it's one pass through all, and we have 150 epochs. And you can see the accuracy. So accuracy is gradually improving. First it is 0.34, gradually improving. 0.7, 0.7, 0.74. So we have done some good work. So next we'll evaluate the Keras model. So we have the file name. So if you have a look at the data set, first artificial neural network, we do the necessary imports, then we load the data set, define the Keras model, then we compile, then we fit the Keras model on the data set, and now we are evaluating the model. So this is how we do it. So you can always it's very easy with Keras API. Print. accuracy. This is normal Python code. Accuracy. So let's make it to 100. So we have 75.65 as the accuracy. So we'll run it again and again. So we'll have several values. 75.65. So it's not a bug. It is how neural networks work. So each time it produces new accuracy. So we can see the average is almost 75. So we have successfully created our first neural network, and we have done the evaluation as well. So we'll just have a quick recall. So first neural network. So first we do the necessary imports. Then we loaded the data set. Then we split into input, which is X, and output, which is Y. So 0 to 8 columns. So we took 0 to 8 columns. 4, 5, 6, 7, 8. 8 columns as the input feature, input vector. And the last one, which is diabetics or not, as the output. So then we define the Keras model. So in this line, it does two things. It has the input layer, which is 8 neurons, the dimension 8, and the hidden layer, first hidden layer 12 neurons, second hidden layer 8 neurons. For both we have the rectified linear unit function, activation function, which produces more efficient output, and for the output layer we used sigmoid function because the output layer it is a binary classification. And next we compiled the Keras model. So to calculate the loss we use binary cross entropy and optimize Adam, so that is stochastic gradient descent. And then we fit the Keras model on the data set. We had it 150 epochs, batch size 10, and then we evaluated. So congratulations, your first neural network is up and running. So you can have a look at the documentation in order to find more details about the Keras API. So finally, congratulations once again. So it's up and running. Thank you very much. Hope you enjoyed the session. Thank you.